Good morning and welcome to Spring 2026 0151, Math 0151. I'm glad that everybody did the zero lesson or the zero model. And now today we were going through the model number one, that is polynomial operations. Before go to polynomial operations, I would like first of all to give you some background about polynomials. First of all, I want to define what is a term. No, and I will define that graphically. A polynomial term is something that is right in the form of a times x to the n power, where a always is a real number, x always is a variable, and when we talk about variable, we talk about any letter of the alphabet and then n is a non-negative exponent. That is the three parts of a term. And I will give you an example of a term right now. No, for example, we have the 3y squared. No, 3 is your real number. And if you have problems with understand what is a real number, shoot me an email and I will send you a lesson that I prepared a long time ago about real numbers. Well, all the non-real numbers and unreal numbers. Send me an email and I will send you this video plus lecture notes. Then y is your variable and 2 is your exponent. The real number is called a coefficient. And we need to remember this name because in the first question of this assignment, you will find probably to define what is the leading coefficient. The coefficient is the numerical part of the term. So also I want to there are three kind of what let's review, three kind of polynomial. Let's see four kind of polynomials. Four. Okay. The number one is a monomial. And a monomial is made by one term only. No? One term. An example, again, we'll put the same one, 3y squared. The second kind is a binomial, and it's made by two terms. For example, 3y squared plus 3y. But in mathematics, we don't write the ones, like neither in physics and chemistry. There is always an understood one, and this y have an exponent 1. I will give you this clue, no? If you have a variable, a letter, and don't have a coefficient and don't have an exponent, the default coefficient will be 1 and the default exponent will be 1. And then you have a trinomial. A trinomial have 3 terms. No, an example of that would be 3y squared plus 3y plus 5. You have 3 terms. But this term in the end is called a constant. And we will use this name a lot when we are doing factorization. No, and another way to write this is 5x to the 0 power. But you know that every time that you multiply, you write any number or any x represent a number. So you write any number to the 0 power as 1. So that would be like 5 times 1, that is equal to 5. But this number, the constant, is a polynomial. Why is a polynomial? Because it's been written to the form a, you have a real number, 5, you have a variable, x, and you have a no negative exponent, 0. So you can say that a constant, 5, also is a polynomial. And then anything after that we call polynomial. I will give you an example, no? Anything that have more than 4 terms, we call a polynomial. No, for example, 2x to the third power minus 6x squared plus 3x minus 9. You can see there are 4 different terms. And you can have 6 terms, you can have 8 terms. Anything over 3 is called a polynomial. But also, the monomials, binomials, or trinomials are a subcategory of polynomials. There's all are polynomials, but when you have more than 3, we don't give it any special name. Only polynomial. Well, with this introduction, I want to, and I'm recording this for you. You can go back and you can check and do your notes accordingly. You know, note takers are always test makers. And the reason is because when you do your own note, this note makes sense to you. So let's do our first example. I will give you an example of everything, and only will have 50 minutes to do that because I have a class after that. But for example, the first question you will see will be something like, again, we'll give you the same. plus 3y plus 5. So we know that these polynomials have three terms. One, have two, and three terms. And because our three terms, one of the questions is they want to know what kind of, if this polynomial is a monomial, this polynomial is a binomial, or is a trinomial. And the answer would be that it's a trinomial because have three different terms. And then the second question they want to know is the degree. We already said that if you see that a variable, a letter, don't have a coefficient or a power or exponent, the default is 1. So it's these y have a 3 as a coefficient but don't have a power, so we can put 1 as a power exponent, and then all constants that we already explained in the first part of this video are raised to the 0 power. Because you have 2, 1, and 0. Just to find the degree, you need to find out who is the higher exponent, no, or power in this trinomial. So you can see that the first term is raised to the second power. The second term has been raised to the first power, and the third term is 0 power. The who is the highest or the higher degree of polynomial or exponent? Of course, 2. So that you can say that the degree of the polynomial is 3, is 2. Is 2 or second power. And then the last question that we're asking is, who is the leading coefficient? Well, the leading coefficient always, I'll put here, no, the leading coefficient is the number that is multiplied to the variable, the letter, with the highest exponent or power. Because what is the number? Now we have three numbers here in this trinomial. We have the number 3. The first term have a number 3. The second term have a number 3. And the third term have a number 5. Which of these is multiplied to the variable or to the letter that has the highest or higher exponent or power? Of course, it's 3. The first 3, this one. This one is the leading coefficient because it's multiplied to the variable, the letter y, that is raised to the highest power. You can say that the leading coefficient is 3. And that is the first and second, probably your third question in your assignment. Um, then you will have a question. If a constant, they will ask you if a constant, for example, negative 15 is a polynomial. And we already said in the first part of this video, this negative 15 that can be the end of a polynomial. You have, for example, 2x minus 2x to the third power plus 12x to the second power minus 5x minus 15. So this negative 15 is the constant. Negative 15 is the constant. And we already said that another way to write the constant would be negative 15 x to the power of 0. And negative 15, any number that you rise to the power of 0 is become to be 1. So it would be negative 15. So because it's right, and that is the way that we write any polynomial, no? It's a, that is your coefficient, multiplied to a variable, to a x, and to the n power. So it's because this constant suffice and comply with all the requirements to be a polynomial expression, no? A polynomial expression, we can say that yes, it is a polynomial, and the degree of this polynomial is 0. No, negative 15 is a polynomial, and the degree of this polynomial is 0. Well, that was another kind of question that you will see in your assignment. Let me keep moving. And if you need more in-depth explanation of any of these questions, please shoot me an email, because I'm trying to cover the most I can. So let's do now about polynomials. Polynomials can be added, subtracted, multiplied, and divided. In other words, you can perform any arithmetic equation in polynomials. So let's try this time to do a subtraction of polynomials. Negative 3x minus 7x. Also, I want to use this example to explain one more thing. You know, the only reason that we can subtract these two polynomials because are like. What make two polynomials like? Because both have the same variable. Both have an x as a variable. And again, the understood coefficient of power, if you don't see a power in 3x, you know the power is 1. And if you don't see a power or exponent for 7x, is 1. So it's because both have the same variable and are raised to the same power, made them like. And because that, we can perform our operation, we can add them. All right, if you remember the rules, no, for signs, no, when you subtract two signs, it's like you are adding them, and the answer will be negative. So you have negative 3x minus 7x will be a negative, and will be a negative 10x. Now, let's do an addition. Imagine you have a negative 2x cubic plus 12x cubic again. The only reason we can add these two polynomials or two terms is because both have the same variable, the same letter x, and both are raised to the same power, to the third power. And we know in the rules for signs, when you add and subtract, that if you add and you subtract a positive or add a negative, always you carry on the sign of the bigger number. Who is bigger, 12 or 2? Of course, 12 is bigger and 12 have a positive sign. Then my answer will be positive, and then you subtract 12 minus 2 is a 10, will be a x cubic. That will be the answer. If you need a refreshment about the rules for adding the rules of sign for adding and subtracting or multiplying and dividing, send me an email and I will send you a lesson that I made long time ago about that. Another example that you have is when you have more than one in this example 3, I give you two terms that are being subtracted and two terms that are being added. But what happens if you have more than two terms, like this one? You have 2x squared minus 6x plus 3x minus 9. No, again, no, in this polynomial, because have more than three terms, remember the powers of the middle terms are 1 because they don't have a power, so you can say that the default power is 1. And as you can see, I can do nothing with 2x squared and nothing with negative 9 because there is not like terms to combine them. The only like terms I can combine is the middle terms, negative 6x plus 3x, because both have the same variable, the same letter, and both letters, the x's, are raised to the first power. So I will have to rewrite again the first one because there is nothing to combine. Then I will see who is greater, no? Who is greater, 6 or 3? Of course, 6 and 6 have a negative sign. Then the answer will be negative, and I subtract 6 minus 3 is a 3. Will be a 3x, no? And then there is nothing to combine the 9. I will rewrite the 9 again, that is the answer. I want to give you another example of a several step equation. Imagine you have parentheses, you have a 4x minus 1 squared minus 7, and you have a 4x minus 1 plus 10. So you to be able to take these terms outside the parentheses, first of all, we need to apply in the ones that is required the distributive property for multiplication. The first parentheses don't have any number in front, but it rises to the second power. Some students commit the mistake to say that is equal to, say, 4x squared minus plus 1, because they said, no, sorry, even though 16x squared plus 1, because they said 4 squared is 16 and x squared is x to the second power, and -1 times -1 plus 1, but that's not the answer. Because that is the same thing to say 5 squared. How you expand this 5 squared, 5 times 5, because the exponent is telling you how many times you have to multiply by itself whatsoever terms you have inside of the parentheses. So that would be equal to, say, 4x minus 1 times 4x minus 1. So now we have to multiply these guys first of all. I'll put in a bracket. And then the second parenthesis have a -7 in front. That means I need to apply the distributive property of mathematics. For multiplication, I need to multiply this -7 as I am taking everything out of the parentheses. I need to multiply -7 for the terms inside the parentheses. And you have a -7 and you also have a +4. Negative, when you multiply a negative and a positive, the answer will be negative. And 7 times 4 is a 28, 28x. And then -7 times -1 will be a +7. Negative and negative, when you multiply to negative, become a positive. And then I can put my +10 there. Just to be able to finish this equation, I need to FOIL. No, I need to FOIL these two parentheses. And FOIL means you multiply the first term in the first parenthesis by the first and then by the second term of the second parenthesis. And then when you finish to that, you go back to the second term in the first parenthesis, in this case -1, and you multiply them also by the first and second term in the second parenthesis. So let's do that, no? 4 times 4 is a 16, and then you have a 6. You remember when that is a default power of 1. When you multiply polynomials, you only multiply the numerical part of the coefficients, and then you add the power of the exponent. That will be 16 and x to the second power. And then you multiply again the first term of the first parenthesis by the second term of the second parenthesis. It will be +4 times -1 will be a -4x. Then you go back to the first parenthesis and you do the same with the second term. -1 times +4x will be a -4x, and both have a 1 as a power. And -1 times -1 is a +1. Then I can combine like terms. The only like terms I have is the middle terms. So I will have to rewrite again 6x squared. And then -4 and -4 we said in the beginning, in the first example, number 3, that when you have two negatives being subtracted together, it's like you are adding these two numbers, -4 plus -4, and the answer will be negative. Will be 8x, and you do nothing with the exponents. Only you add or subtract exponents. You add exponents if you are multiplying these terms, or you subtract the exponents if you are dividing the terms. But in the case of the middle terms, we are adding them together. Then we only write the variable, the power again, and then there is nothing to combine plus 1, and that is the final answer. Then we cover in this one, not only we cover subtraction and addition, but also multiplication. I will give you another example. Let me erase that. I will try to give you all the examples I can in the time frame. I only have 5 minutes more. Let's do another subtraction. And let me do one with 2 examples that I need to give you. they are asking you to subtract and see the term subtract 2x squared minus 5 from. Now, when you hear the word from means these second terms are the one are going in the front because you are subtracting 2x squared minus 5 from 2x plus 4. So I will have to go in parentheses 2x squared plus 4, and then I'm subtracting from them, no, minus 2x squared minus 5. Remember, in the first term, the first parenthesis, there is nothing to distribute there. So I can go and say 2x squared plus 4. But I need to distribute, multiply this negative sign in the second parenthesis. I need to distribute, multiply, no? And then you have a negative times a positive 2x, no? Doesn't look like a positive 2x. When you multiply a negative times a positive, it's a negative. And then you put your 2x squared. And then you have a negative 5. You multiply negative times a negative is a positive, will be a 5. Now you have everything outside the parentheses. The next part is to work with your like terms. You have a positive 2x squared and a negative 2x squared because are the same term but opposite signs, they cancel out. And then you have a 4 plus 5 is a 9, and that is your final answer for this question. Let me do one with fractions. And that will be the last one that we'll touch today. And again, no, if you have more questions, send me an email and I will help you in all that you need. Imagine you have a question like this 20 times 1 4x no plus 2 over 5 y. It's again, no, I have an equation, have two fractions. I need to find the LCD or LCM. Because I cannot add two fractions, 1/4 and 2/5, because have different denominators. If you remember when you are doing in middle school fractions, to add and subtract fractions, they need to have the same denominator. So I need to find who is the LCM. And if I multiply 4 times 5 is 20. So as I can say, I can multiply 20 for each one of the fractions. And 20 over 1 times 1 over 4. Because I'm distributing this 20, because I find out that 20 is the LCD or LCM, I will use the 20 to this as I distribute inside the parentheses. Also, I am taking out or reading out the fractions because you want to have a linear equation all the time that you can. So it will be a 20 over 1 times 2 5s. This guy have a y outside. So I will do the first, how many times 4 is in 4, 1 and 20, 5 times. Do you see I cancel the denominators? And the only thing I have is 5 times 1 times x because you can know or forget your x. So it will be 5x plus. Then I go to the second parenthesis and I go how many times 5 is in 5 is 1 and 24 times. So I have a 4 times 2 times y. That will give me 8y, and that is the end of this equation. And the reason is the end because I don't have like terms. Because both have a 1 as a power, but 5 is multiplied to x and a is multiplied to y. And because that there are not like terms. To be like terms have the same variable, the same letter, and rise to the same power. That is all for today. Again, if you have more questions about polynomial operations, send me an email and I will happily answer your questions in order to do that. How you doing, Terry?
I'm good.
Terry, did you send me an email because you will be absent today?
I'm sorry.
Did you send me an email because you will be no. Okay, you are doing the 0151?
The pre-calculus class at 9:30.
Yeah. Remember, you are a face-to-face student.
Yes, I know.
Do you send me an email? Let me know why you cannot be in class today.
I can still make it to class today. Did I send you an email?
I don't see any, but if you want to be online today, send me an email and give me a reason because you cannot be in class today.
Okay, no, I can make it to class.
Okay, okay. I will, but if one day for any reason you have something that happened and
Hmm.
hindered you to be in class, you please send me an email before the class,
Okay, I will. Thank you.
and you can be online.
Okay, perfect.
I will see you in class then. I'm
Okay.
preparing. That is a class that I'm giving to another section. It's called 0151. Are you in the 0151 too?
Let me double check. I'm pretty sure I am.
And there's this video that I just record is for you also. I will end the video right now because I need to